In this video, we'll consider the air pressure that's in the tires of a vehicle and what that means about the area of each tire that's touching the ground. It says the tires are inflated to 35 psi. That's the pressure in US customary units. So psi is pounds per square inch. We'll be needing to convert that to SI units, but we can actually answer the first question before we do that. So the 35 psi, is that gauge pressure or absolute pressure? Well, if the tires have no air in them, there's not a vacuum inside the tires. They're full of 1 atmosphere of air. So when you put a tire gauge on the tire to see what the pressure is inside, it will read 0 if the pressure inside the tire is actually the same as the pressure outside, atmospheric pressure. So this 35 psi is measured by a gauge that we put on the tire. It's measuring the gauge pressure. So 35 psi is the gauge pressure. Then how much area of each tire touches the ground? Okay, so I've drawn my Sienna here. In the view here you can only see 2 of the tires, so I made sure to write there are actually 4 of them. So we're given the weight of the car in pounds. I've already converted it to kilograms. And we were also given the pressure, 35 psi. I converted that to pascals as well. And noted that there are 4 tires, and we're looking for what the area is of each tire that's touching the ground. So the tire has some amount of surface that's touching the ground. It's that area that we're interested in. So how can we figure that out? Well, if I make a free body diagram, I know that there's mg pushing down on it, and then it's also being lifted up, right? So mg pulling down, and on each of these areas, there is some force that's pushing up. That's the normal force from the ground that's pushing it up. And that normal force has an equal and opposite force from the tire pushing down on the ground. The normal force is equal to mg, which is equal to the force on those total 4 areas. So the pressure is force per area. I know the total force is going to have to be mg, and the total area is 4 times the area of 1 tire. The thing we're looking for is the area of the tire. So if I rearrange, area of the tire is mg over 4 times the pressure. So 2045 kilograms times 9.8 meters per second squared over 4 times 2.41 times 10 to the 5th pascals. 0.02 square meters. That's how much of each tire is touching the ground. Does that make sense? I could get that by multiplying 0.1 meters times 0.2 meters, right? 0.1 meters times 0.2 meters, that's 10 centimeters. So about this much, times by 20 centimeters, about that much. That looks fairly reasonable for the amount of a tire that's touching the ground at any point in time. So this looks like it's a reasonable answer. That's the area of each tire touching the ground. Now if the pressure was higher in the tire, then there would be less area touching the ground, right? And so what would happen is actually the more or less flat bottom surface of the tire will bow out more, so that you get a smaller area touching the ground. If there's a smaller area touching the ground, that area will wear out faster. So if your tires are getting bald in the middle, if they're wearing smooth in the center, that means there's too much pressure in the tires. If they're wearing out on the edges, that means there's not enough pressure.